Our final presentation for the evening, we are joined by Tom Wolf with a look at innovations in pesticide application technology, such as spot spraying and drones. For those of you who were not here today, Tom is a spray application specialist based in Saskatoon. He grew up on a farm in Manitoba and studied agriculture at the University of Manitoba and the Ohio State University. Tom has 35 years research experience in spray technology, starting with AAFC in 1989, and is now a private consultant. With Jason DeVoe, Tom now hosts and writes for the world's #1 sprayer website, sprayers101.com. He's a past president and fellow of the Canadian Weed Science Society and is named Distinguished Agrologist with the Saskatchewan Institute of Agrology. Welcome.
All right, we're going to have some fun. Look at some new technologies. Thank you for the introduction. Hopefully you'll find this enjoyable. It's perhaps the two most interesting things to have happened in agriculture in a long time. Probably the most exciting thing since air induction nozzles and pulse width modulation. Okay. So here we go. I do want to quickly acknowledge my two co-authors. Guy Coleman is a University of Sydney a PhD student who's doing thermal methods for weed control using artificial intelligence to identify them. He's really probably the most knowledgeable person that I know of on artificial intelligence in ag at the moment, in vision. And Jason DeVoe is my partner in Sprayers 101, and he did provide a lot of the slides for the drone section. So Jason and I are working together on drones, and Jason is not quite as active in the spot spray as I am, perhaps. But I wanted to just show this slide about the general prevalence of herbicidal spraying, at least in my world in Western Canada. And we can see that we're using, post-emergent or pre-herbicides. Before we seed, west of Brandon, almost every acre gets a pre-seed burn-off prior to seeding our spring crops. There's almost no winter cereals. After some mid-season insecticides and fungicides, we then go into pre-harvest and desiccation, which is also a potential for spot sprays in this, as well as post-harvest. So we can see 4 herbicides on a field in any given season, and each of them has different levels of potential for spot spraying. Why spray everything? Why do we broadcast spray? Why don't we spot spray? It's because weed maps are difficult to obtain and they don't last very long. Soil maps, texture, fertility maps, cation exchange capacity maps, they're generational, can be, texture certainly, not nutrition, not so much, but we can do a grid sampling and have something to go by for at least 1 year, maybe more. For weeds, we have something to go by for maybe a month, and then it rains and something else happens. And the first adopter of spot sprays, green on green, Andrew Messina here, was quoted as saying, I wouldn't spray the whole field if I knew where the weeds were. And essentially that's a very true statement. The first one to make it into Western Canada is green on brown. I first saw my first green on brown spot sprayer in 1992. That was in Assiniboia, Saskatchewan, on Kelly Johnson's farm. He had an NDVI system that later became the Weed Seeker and the Green Seeker. It never went anywhere because he decided to get into it when glyphosate was still $30 a liter, and promptly went down to $4. And so the spot spraying became uninteresting in the pre-seed burn-off, economically uninteresting. This technology here that's pictured is the Weedit, and the Weedit is a Dutch technology from Romatron, and it started off as a sort of a sidewalk, sort of industrial use where you'd spray cracks in the pavement or the gravel or something and just get rid of the weeds as they come up. And they saw a use for it in Australia. And now there are hundreds of weeded units in Australia. And if you haven't been to Australia, they grow their crops in their winter and they have chemfallow in their summer. It's too hot and dry. So that means they spray all day, every day, all summer long to keep certain weeds under check because they just keep on growing. And spot sprays are ideally positioned to get rid of those weeds. And we've tried this in Western Canada, and I've helped Romatron get established here with Weedit. And we've got about, well, they have probably about 20 units running in Western Canada right now. Here's just a video, if you haven't seen a spot sprayer in action. This is a video from Brazil. I like it because it hits all the high points. So you can see it's a clearly spot spraying these rather large weeds. They can go down to a thumbnail size weed, so that's a possibility. Works day and night. emits a light that detects chlorophyll. Chlorophyll gives a different wavelength signal back, and it says, okay, that must be a living plant, therefore let's spray it. The sensors are spaced at 1 meter and have 4 channels, and each are 25 centimeters apart. You can see spot sprays are pulse width modulated, so they're turn compensated and can work really well. They also have them in Europe. They're not as popular in Europe. There's less pre-seed, but Amazon has the rights to distribute in Germany and East. And it seems to be working. What you see here is all nozzles running. So all the nozzles are doing a broadcast, and you still see spot sprays, right? So that is in a situation where you have really tiny weeds that the sensor can't detect. So smaller than a dime, let's say. And you may still need to get those. So what you do is, if you're doing a liter of glyphosate as a pre-seed burn-off, a liter per acre of glyphosate, you might then say, well, a third of a liter is actually a registered rate. It was the first rate of glyphosate for pre-seed burn-off. Still will kill tiny weeds, and then use that as a broadcast, and then you spot spray the full liter on the spot when you get the sensor telling you, okay, that's a big weed. Enter green on green. So that's established. That works well on large farms. It's expensive to buy. It's a $250,000 investment on a sprayer, green on brown. Not everybody wants to buy that, but on a farm of 5,000 to 10,000 acres, that will pay for itself in 1 year. Okay, so the ROI is tremendous. It depends on how often you use it and what kind of expenses you incur. Green on green has likely got a much more broad appeal because now you can spray weeds out of crops. And all green on green systems have the following 4 components. First of all, they have an RGB camera. This is a regular video camera, not super high res, close to the canopy though, so it has a fairly high res picture. And it has a processor full of graphical processing units. It's an NVIDIA usually. So anybody who's into gaming or artificial intelligence knows NVIDIA has the market. So that's what's in that box there. It's cooled. There are solenoids that have a 5 millisecond response time, so they will turn on and off real quick. And then there's this secret sauce called the algorithm. And the algorithm is a large model. So it's a large mathematical model. It has approximately, we don't know what these algorithms are, but the algorithms are public domain right now for image recognition in agriculture, have about 100 to 200 million parameters. So they're large models, and these processors are required. They'll take a pixelated image and they'll have thousands of pixels on them, and they'll do the grayscale value of each of those RGB channels, and then they will figure out whether that's a weed or not based on filtering and associating locations where the images are. And that has to be done in 150 milliseconds. So the image looks ahead, the sprayer is driving 15 miles an hour, the processor says, okay, in that lane, so there might be a camera every meter for a weed, for example. There is for this one. This is the ASC Plus, the bilberry. It's once every 3 meters. It'll divide that image into either 4 lanes. So it divides into 25 centimeter lanes, basically. So if there's a weed in that lane, you turn that nozzle on. Okay, so it does all that. It does all of that in 150 milliseconds. So it's a very smart thing. Okay, how many redwood pigweeds were there? All right, I know that was a trick question. 4. Okay, are you ready? How many redwood pigweeds? Because that's 150 milliseconds, guys. All right, I just want to illustrate the magnitude of this accomplishment. It's not inconsequential by any means. So there's 7 pigweeds in there. So I don't know whether an AI can do this. I could. It took me about 10 minutes though, and there are certain shortcuts that are currently being used, and I'll explain those to you. This is the John Deere See and Spray Ultimate. You can buy this in the US. You have been able to buy it now for 2 years. It is a $250,000 option, usually bundled with Exact Apply and discounts for being a loyal John Deere customer and this and that. All of these boxes that you see here are NVIDIA laden processors with cooling fins. There are 11 of them on a John Deere See and Spray Ultimate. That sprayer has more computing power than you have ever been in the presence of, I guarantee you. Okay, that's what has happened in ag. We are on the forefront of the artificial intelligence revolution using image processing. We are on the forefront, okay? So this is the bilberry. This is in Australia. It's seeking wild radish in lupins. And they're spraying wild radish under lupins right now. It's a very difficult weed to control that's resistant to many things. They use very expensive tank mixes, and spot spraying is an ideal candidate for them to do that. And there are early adopters that have been doing it for years. Okay. This is the bilberry system on a diamond sprayer. This is on, again, I mentioned this morning, Sir Dyson. This is his farm again, okay? They're just doing some green on brown stuff with the bilberry system. It's a French system bought by Trimble a couple of years ago. So it seems to be working, okay? All right, green on green. 3 ways of doing green on green. The first one is to use a green on brown sensor. Okay, so this would be a reflectance-based system that just simply says, all right, we're going to adjust a threshold. And, you know, in this case, this picture on beside is canola, seedling canola in the codling stage. You can't see it, but you can see these 3 patches of winter annuals, shepherd's purse or something. So you set the threshold so that the nozzle doesn't get triggered by the seedling canola, but gets triggered by the much larger rosettes. And you have a spot sprayer green on a reflectance system. People are doing it that way. The second way, and this is where all the action is to do artificial intelligence. So it takes this picture, it says, this is where the weeds are, this is what I think kind of weeds they are. They can maybe not speciate them right now, but they can say if they're broadleaf for grass for the most part. And then they will activate a nozzle in that lane, okay? And then, of course, there's the shortcut, and that's what we're currently seeing. So this is now the implementation of green on green in row crops. So they're basically saying, we're going to identify the row crop, and we're going to identify the row. And in that row, we're not going to differentiate weeds from crops. We just say, okay, everything in between, if it's there, we don't actually care what it is. It's probably not a crop, and we're going to spray it. So it's a little bit of a cheat, and that cheat is being reduced over time as it gets better and better at identifying the weeds, okay? This is a bit of a hybrid. So I have 6 observations. The first one is very promising. So early, I've been on several of these sprayers. I've written up about them on Sprayers 101. They are working, and the early adopters, they're not too scrutinizing. Why are they buying this sprayer? Because they believe in the future. They want to become acquainted with it, and they want to see if it works on their farm. They're large farmers. They're not that concerned right now if this is going to pay for itself. They want to dip their foot in the water, basically, okay? What's exciting about it for me is what it provides us as agronomists, as agronomic tools. So certainly savings, okay, that's the entry point. But you have, weed-specific herbicide rates are possible because you may be able to speciate. And you can control the rate with pulse width modulation. You can have more effective mixtures for the resistance issues. If we do multiple effective modes of action tank mixes, that means we're going to be putting not a $10 burn-off, but a $50 burn-off concoction together that may not be economical on a broadcast basis, but is economical on a spot spray basis. So we're investing in the future, okay? Less spray drift, obviously, alternative control measures. We don't have to spray. I mean, if we know where the weeds are, we can choose the control method. It may be cultural, it may be mechanical, maybe thermal, maybe some other way. And exciting for me is the future for species composition, cover cropping, intercropping, and saying, all right, we've got 4 species here, but one of them is out of place. One of them is harmful. Let's get rid of that one, okay? So, that kind of specificity is going to be possible. Not right now, but we're rapidly achieving that kind of option. The costs, though, are, we have to be careful about the costs. So it's not just the hardware, it's also the software. So for example, there are use fees. John Deere charges $3 an acre for corn every time you pass over the field, and $4 for soybeans every time you make a pass, and $4 for cotton. So that means that if you have a 3-pass system in soybeans, you're going to owe John Deere $12 use fees per acre at the end of that year, right? Very serious. Some of them are free. So that could differentiate. What it really means is it may not pay for cheap generics. Because if you pay a $4 use fee and you still pay, say the generic costs $5 per acre, all right? If you pay a $4 use fee to use it, and you still use $1 worth of herbicide, it's $4 plus the $1, it's $5, it's the same cost. But one of them has a risk associated with it, and that is this. You have the risk of a spray miss. You have the risk of maybe having to respray because of that spray miss, or maybe you have additional complexity in the hardware. You have all kinds of downsides to this technology. So you do have to be very careful about what you're entering. Boom height control is absolutely critical. And we're terrible at boom height control in the spray world right now. The wheel might come back, the outrigger wheel might come back, might need to come back, in fact, because our sway is too large. We have fallback mode in all of these systems, which means if the camera isn't sure that it can identify the weed because the boom's too high, all the nozzles go on. Just in case, because it says I can't see. If there's dust, all the nozzles go on, just in case, because it can't see. So it's always going to be on the conservative side. If you have a single nozzle activation, then the boom height is incredibly important. If it's too high, the dose is reduced. If it's too low, the dose is increased, and you introduce gaps. Okay, let me show you some examples of this. I don't even have too many, but just 3. So let's say your boom is set at 27 inches, and you've got a 30-degree fan in there on 10-inch spacing, which is typical. You're going to be spraying a band about 15 inches wide. So you have a little bit of overlap to the next band. It's a 10-inch wide band, but you're spraying 15 inches. If you lower that boom by 10 inches, it's not that much. 60 feet over there, it's not that much. Okay. Your band is now 9 inches wide, and you are overdosing 60% and introducing gaps. And if it sways the other way and goes up, your band is now 20 inches wide, and you are 30% underdosing because it's been diluted. That's for a single nozzle activation. So, that's going to be important. And what a lot of people are doing is they're activating more than one nozzle. Right? They're saying, I can't risk that. I'm going to activate 3 nozzles adjacent to each other, which limits your savings potential to some degree. Okay? So nozzle choice is in fact limited. We're using older steel nozzles for this right now. There's some custom-made ones. This is the one I'm showing here is a DG T-Jet, which was made for Green Eye by T-Jet, and it has a pre-orifice, so it's low drift. It's a narrow fan angle. It's a great nozzle, actually. And then we see some new ones. Greenleaf, for example, has the spot fan. Wilger, a Saskatoon company, has introduced 20, 40, and 60-degree nozzles. And Magnojet, a Brazilian company, has introduced a great spot spray nozzle as well. Other than that, the pickings are slim. Okay? So algorithms may be regional. When bilberry came to Saskatchewan, there's a bilberry sprayer just north of where I live in Saskatoon. They had to say, all right, what is kochia? That was an important question for them to answer. And what are lentils anyways? So they have to now teach the cameras to identify crops and weeds that they have never seen before, which may require at minimum 10,000 weeds to be annotated and possibly 30 or 40,000 weeds to be annotated, each of which costs 10 euros for them to do, and time. It's a human task, annotation. So, do they have a commitment to add rotational crops that you might be interested in the future on your farm? So that's an important question. Right now, John Deere's doing cotton, corn, and soybeans with no commitment. Maybe they have a canola commitment. Bilberry's doing wheat, Bilberry's doing canola, Bilberry's doing lentils, in addition to the row crops. But that matters, right? That actually does matter. Dual tanks are useful. And I think that there's a great, there's basically dual tanks. You have one pre and one post product. The pre has the large tank, the post has the small tank. The pre is broadcast, the post is spot sprayed, simultaneous. So that's an important system in a corn soybean row crop production. And I'm going to show you that in a second from some data. And it does save that extra sprayer pass. And a sprayer pass, in my world, costs between $8 and $10 per acre, fixed and variable costs, fuel, labor, depreciation. Okay? This is a slide that I got from Rodrigo Worley. Dr. Worley is a professor of wheat science at the University of Madison. I saw him in January. And I asked him if I could borrow the slide. So he showed just the importance of a pre when you're doing an early pass system. So this would be a pre-seed residual. On the left side, you see that the Palmer amaranth or the water hemp, I'm not sure which one of those that is everywhere. When he's done some fierce, he's got significant reduction in the competition when the crop is up. When he's added dicamba to it, he's got even more. Now, if you wanted to control those residual weeds in the two right frames, he can implement a spot spray. If he hadn't done the pre, he wouldn't have been able to implement a spot spray because it would have been a broadcast requirement. Okay, so a pre has set that system up for a saving and a potential better tank mix. So it's a nice system in my opinion. This is in Fargo. I was down in Fargo in January. I consulted with this company, Green-Eye, to get them set up, and they produced a sprayer. They're selling the sprayer, Green-Eye. I wrote up my trip. Lights they flash, so they illuminate the image that they're taking, and it's also night capable. Okay. This is a dual tank system on the See & Spray Ultimate. It's color coded. One is the spot spray and two is the broadcast spray, 2 pumps, 2 booms, 2 everything. This is the tank that Green-Eye puts on their spray. They put a smaller tank on for the spot spray and they keep the bigger tank that pre-existed in place. And you can transfer between those 2 tanks if you wanted to. Yes?
Just curious, how do you know how many acres to mix for the spot spray?
Yeah, exactly. It's a good question. And you don't until you become experienced at it. And most of the people that I've dealt with that are users of spot sprays say, you figure it out. So, you know, right now we're doing a lot of burn off on spot sprays, and of course you might do your whole farm with the same kind of tank mix, so you can carry it forward. At the end, when you're done, you just broadcast because it's legal and possible to do that. You put the rest out there. That's how they deal with it. But if you were going to do a spot spray on a 40-acre patch and then change your mixture, do a 30-acre patch somewhere else with something different and so on, you would have a hard time figuring out exactly how much to mix, and especially if it wasn't your field. If you're doing it for custom, absolutely. Serious, yeah, very good question. John Deere has a dual boom system, so they have 2 plumbs. So these are 3/4-inch lines, and they lead to the same exact apply body. You notice on the back of this body that they have a backward facing. So they have a 40-degree backward facing mandatory angle, and that buys them extra time. So that if you can look at the See & Spray Ultimate here, it's spraying all their nozzles backward. It gives them extra time. The camera's looking forward. It's just another half meter. It's another 50 milliseconds. So they can do more processing, be a little bit more sure. Okay. And on all the cameras, their cameras, I believe, are every one meter. They get this image here, and they see the rows, and then they see the weeds. They're identified and color-coded. And it's actually, from an agronomic perspective, I'm excited about this part. This is the as-applied map. Okay, this is like your weed map. It doesn't tell you what weeds it is, but that is coming. From an agronomic perspective, I would love to know where my weeds are and what species they are. Every time I make a pass over the field, I get a new updated map. Scouting problem equals gone. Okay? No more quads driving over your fields. Notice that in this case, this operator, oops, sorry, my bad. They have, their as-applied map shows a streak behind the sprayer. That's the fallback mode, dust. Okay. This is an as-applied map from One Smart Spray. This is again from Rodrigo, and you can see these fields that they applied, and it's probably from Zarvio, I'm not sure. I got it from Rodrigo. But you can see the patches that were treated. I mean, these are huge patches here. Maybe agronomically not that interesting, but you can see the as-applied sprayed map, and then they have a weed map on the bottom, which is not as easy to see, but hopefully will be useful in the future. This morning we talked, somebody asked a question about Croptomistic and the SWOT maps. They're being used in the East, and that's great. That's a company out of Nacum, Saskatchewan. I just wanted to put this in here to make you aware that they're also in this game. What they're doing is they're doing the SWOT cam. And this is it, oops, wrong. This is it right here. It's a Samsung Galaxy. But they are taking pictures, and they're associating those pictures with their SWAT zones, and they're developing prescription based on the SWAT zone resolution, not weed by weed, but zone by zone. Okay, so that gives them now the capability of also doing row finding, just like everybody else, and they have algorithms for kochia, and they do stand establishment counts with this. So they're not counting every plant, but they're taking a number of pictures per acre, and they're saying, okay, for this acre, this is the plant stand. So I think it's an incremental way into this field, okay? Okay, that is my halfway point, and I've got 5 minutes left. But fortunately, this is just videos, okay? So this is drones. This is Jason and I. We're in this space because we think it has utility, but we're apprehensive about it because we've seen some stuff that isn't good. Whenever you do aerial applications, you will use less water. 10 gallons is not an option, and especially for drones. In the drone world, we're going to be doing 2, maybe 3 gallons. Okay, that's what's currently being done. And drones also hover. They're in a transitional flight. So a helicopter, when it lands, and you see, a helicopter landing, and everybody's has to hold under their hats. When a helicopter actually sprays, there's no downwash. When a drone sprays, there's downwash. I'll show you what this means. So when they hover, the downwash happens. When they're in transition to forward flight, that's what a drone does. There's downwash. When they're in low speed or high speed forward flight, the downwash dissipates. Okay. So this is a video that Jason took of some trials they did with Dave Hooker and a few of the guys. Maybe Art was involved in this as well. And he took the video to show that there isn't any movement of that canopy from the downwash of that helicopter. Right? Helicopter's flying too fast. It's probably flying close to 100 miles an hour. And if you look at a drone, it generates this kind of downwash. It's moving too slow. So you have this element, and that element is interesting from our perspective. This is a video I took with Jason and I were doing some patternation, and even the corn residue was moved by that. It was slow motion, but he was flying at a normal speed. That's a small drone. Okay, so it's a very important. So this is this is actually University of Dayton. They have a wind tunnel, and what they did is they put these the smoke in on these props, and just you can just see how variable this plume becomes, particularly at the periphery, where you start to get all kinds of interesting vortices and things that are being formed. So it's a very complicated flow field, and if you look at it, you can see all kinds of behaviors, zigzagging back and forth, going straight, developing vortices. So how do you do uniformity? How do you know what's happening? This is the XAG P100 Pro. We flew this in October in Simcoe to do patternation work. We spent 3 days flying drones, and I took this video just to show you just how turbulent and complicated the flow is. I mean, it's vortices are forming. The wind's obviously coming from that shelter belt, but uniformity, not so much, right? It's going to be a challenge. This is a T-30. This is a very popular drone right now. Jason took this video, and you can kind of just see the changeability of, the deposition, just like we had before. And what I did here is I just wanted to take some images. So here you have the trapezoidal deposit. So that's what we call the swath. But you have a cloud that's escaping downwind. A second later, the trapezoidal swath is different looking. Another second later, it's different looking again. And I think we do have to be mindful of that fact. Yes?
Why is that versus the helicopter? Is it the whirling of the rock?
That's right. So it's the point is that this prop is constantly adjusting its rotational velocity. There's usually 4 or 6 props, right? And all of them are operating independently. They're counter-rotating. This one goes this way, and this one goes that way. And they also change their velocity constantly to position the drone appropriately. Well, that's how they steer. That's how they steer. Yeah. But I think it's not a dumb question, because I think they should do something about that, because it's not a consistent flow field. So it gives us trouble, right? Well, let me show it to you. This is a good pattern. This slide right now is a good pattern from a drone. Yeah, that's how terrible it is. And that's, to me, yeah, are you kidding me? I'm not kidding you. Seen hundreds of these. It's not great, okay? But in the drone world, this would be, oh yeah, let's go. Uh-huh. So it is a bit of an issue, and we're doing this a lot, and I'm not super happy about the outcome right now. We'll see what they can do about it. So here's what we've learned. Yes?
Would it help if you lowered the nozzles and had them quite a bit lower than the drone?
And that's what this picture is. When you fly too low, and we've done this, we've got these patterns, you don't allow the downwash to dissipate and spread the spray that's in those nozzles out. You actually need the downwash to distribute the droplets, as do airplanes, for that matter, right? So when we fly too low, we get this bimodal. When we fly a little higher, it becomes better. When we fly faster, it becomes wider. When we go with low volume, small droplets, it becomes wider again. When we have a side wind, it gets skewed. And we have to move upwind. And just imagine this. Say you bought a sprayer and you bought a 120-foot boom, just for the sake of argument, that's what you bought. But it decides how wide it's going to spray every time you make a spray pass. And it doesn't tell you. That's a drone. Right now, that's a drone. Okay. So what we have are these issues that are difficult to control. This is a picture from Steve Lee. He's at the University of Auburn in Alabama. He's one of the leading researchers in drones. He's fantastic. He's a sharing guy. Like he had a well-attended conference last week or 2 weeks ago in Alabama that many people came to internationally. And this is one of the pictures he shared with us. You can see this drone sprayed field with a desiccant. You can see the gaps where the kill wasn't good. You can see the downwind drift. And he says, these are the issues that we're facing right now. The swath width that was entered into that program wasn't the right swath width. But you don't want to go too narrow either, because you might not have productivity, right? I mean, you can't buy a drone for $30,000 and spray 3 meters wide when you could spray 5 meters wide, right? So those are the issues, and there's pros. I mean, I think there are places for drones. They give you logistical advantages, right? Maybe if you don't finish a field because of wind or rain and you have to go back there to do 5 more acres, do you want to drive your sprayer there, or can you just put a drone in the trunk and have it do it? But that's a logistical niche. A low spot, a wet spot that you couldn't get to, you can fly your drone there. That's a logistical niche, right? It can work small areas, it can work difficult terrain. They're a terrific help, for example, in steep sloped viticulture in Europe, and they're legal to spray in Germany and in Switzerland right now, where they replace a handheld knapsack sprayer that is dangerous to operate, frankly. So it's an improvement. They've replaced the same in the rice fields of Asia, which is an improvement, frankly. Are they going to replace our well-calibrated pull-type sprayer that has good uniformity? Is that going to be an improvement? That's the question we have to answer. There is a strong excitement factor.
So back in the 80s, I don't know which manufacturer it was, but they had that small helicopter that was radio controlled for rice fields. And of course, it was a helicopter, so no problem. Is that not an option that might be better than?
You're talking about the Yamaha R-Max. The Yamaha RMAX, and the Yamaha RMAX is still out there. Here's what Yamaha has done, though. They have said, we're not selling this. We are licensing it to operators to use, but they are professionals. You cannot buy this and fly it yourself. You will call someone who will bring an RMAX to your farm and will spray it for you. Yeah, that's what they decided to do. The RMAX also is internal combustion engine, and it doesn't have a large capacity. It has like 40 or 50 liters. You can buy a drone for a fraction of the price of what an RMAX might cost with a 40 or 50 liter capacity right now. That one that I showed you, the P100 Pro, that has a 50 liter tank. So that's the largest drone you can fly right now. And well, that you can buy, right? And there's a few others coming. The issues are, the work rate is still an issue. At best, 10 to 20 acres an hour, at best. So you're limited to low water volumes. There's nothing registered in Canada, as you know. You have this, I talked about this other issue. So we are at a place where we're waiting for registrants to buy into this and to foster the registration of products through the regulatory system, and then support their use with drones. And we will likely see fungicides for corn, for tar spot. We will likely see industrial products for rights-of-way, rangeland, hydroelectric rights-of-way, that kind of a thing. And we may not see conventional agricultural herbicides unless there's a strong desire by those companies to enter into that market and support those products for that. It's up to them. The ball is entirely in their court. So we're just waiting. We're waiting for the risk assessments from the PMRA. So that's it. If you like drones, watch this video featuring Jason DeVoe as Maverick, me as Viper, and Michael Reinke right here as Goose. Yes. Very embarrassing for me, but we did it. We're not as bold as the Peterson brothers. Okay. So thanks for this. I really appreciate the opportunity to talk to you about this, and that would be it. If you have any questions, I know I went over time. Yes.
So are you aware of anybody using drones for, say, seeding cover crops or
Yes.
anything like that?
That's legal, and it's being done, and it's incredibly successful. I've seen well-established cover crop fields that were seeded by drone. I would have never thought uniform, the whole works. They also do difficult terrain forestry seeding with high-value seed, and so they've done that, and it seems to be working. You're still you're forcing the seed down, but you're not really embedding it, so you may need a pass with some kind of a mechanical device to get the seed established. But
Think of it for, it can be pretty wet here in the fall.
Mhm.
And it might be an option down the road for getting covers on, when it isn't fit to go on that ground with cedar.
I see tremendous opportunities for things like that, yes. They aren't that expensive. You can buy a T40, which is the largest drone DJI currently sells in Canada. They've already got the T50, it's not approved yet, and the T60 is already being sold in China. So, but they are getting bigger and bigger, but you can buy a T40 for $40,000 with 3 batteries, a dry and a wet hopper. They're not that expensive. And you open the box, you can fly it, just like a Mavic, same controller. That scares the heck out of Transport Canada. What are the regulations? So any drone, there are 3 categories of drones. Less than 250 grams, that's your Mavic Pro Mini, your Mavic Mini, 249 grams, no license, fly it anywhere. Fly it in this room, fly it over your neighbor's yard. Perfectly legal to do that. 250 to 25, basic license. It's a license that you write an online test, takes about 1 hour, costs $5. Minimum, but you have to pass it, and then you register your drone, and you have to carry that registration and do continuing education on it. So that's what I have. I have a basic license. I fly a Mavic Pro. And then if you want to fly a heavy drone, which is most of the spray drones, then you need an advanced license, which is almost as difficult as getting a pilot's license. I'm exaggerating slightly, but most people will take a week-long course on it. They have to become proficient at a variety of different things. and then they are evaluated while they're actually flying a mission by an instructor. And most people fail that several times until they finally pass it. And then they need a special flight operations certificate from Transport Canada to operate that drone under the conditions that they specify. So that is changing. It's not every flight now. It was every flight. So for example, about 4 years ago, Bayer was going to do some trials with drones, and they asked for an SFOC, and they said, we want to do 7 trials. 4 weeks later, Transport Canada said, we'll let you do 4 of these. Because we don't know who you are, and we don't know if you can fly drones, and we don't trust you. Now, because of the incredible backlog that they have, they're giving SFOCs as a blanket SFOC to trusted operators, and they will be Canada-wide all year long. So now you can take your drone, but it has to be that drone. The drone specific has to be that T40 that you said you'd fly, and you can apply your test materials with it that way. And it's changing. That even those rules and regs are changing. Yeah. There's definitely a fun factor, but I mean, what I always say is it making the situation better? That's really the question that I ask. Fun aside. Like, for example, if you want to spray 20 acres an hour and do a crappy job, wouldn't it be a lot cheaper to just buy that old amenity sprayer that's sitting in somebody's backyard and do it with it? Because that'll do you 10 acres an hour. It'll do not a bad job, actually. It'll do a better job than a drone. It'll be as productive, it'll be cheaper to buy, but it's not fun. Right? It's not fun. So it's not happening. Yes?
Because of all the problems with the application, will the pilot need, do you think, to wear like protective equipment while doing
Sorry, would they need to think about what?
will they need, do you think the pilot will need to use that protective equipment if they're applying like pesticides and they're like a lot of sway and turbulence and you don't know really where they are?
Oh, for protection.
Yeah.
That's a great question. I think that there's actually some activity right now on operator exposure. And so this is another thing that I think is relevant for the drone space. What is a real shortage on farms is labor. That's one of the reasons our equipment is so big. We just can't get operators. For a drone, you will probably need 2 people to fly one drone, and it'll have 1/3 the productivity of your current sprayer, right? And that's partly because of exposure. So first of all, the operator has to be visual line of sight. They can't take their eyes off the drone when it's flying, not legally. And then you have a mixer loader. And that drone is going to come in wet with pesticide. Yeah, they do. They come in wet with pesticide. Now what you're doing is you're putting a nozzle in the top to fill it up. Maybe you're swapping tanks. You're definitely swapping batteries. They're going to be wet with pesticide. So that is an issue. But again, you have to compare it to what you're currently doing. Are you replacing an orchard air blast sprayer that's driven by someone without a cab? In that case, the drone is better for the operator. A knapsack sprayer like we talked about, the drone is better. But if you are currently an operator in a cab, a vented cab with carbon filtration, and you leave the cab when the sprayer's off, and you fill your sprayer with essentially what's a tote system with, which is essentially like closed transfer, you have near zero exposure. So the drone is a step back. I always kind of want to say, what direction are we actually going here? The drone is light enough that a T10, anyone can pick it up, fold up the wings and pick it up. If you don't wash it off before you pick it up, you will get, and the T40 needs 2 people to fold up and pick up, but it'll go in the back of a pickup truck and they're easy to touch, right? Great, well, thank you so much, and I guess we'll see you again on Friday.